welcome back to my channel. I'm Ashley Morse, the owner and lead tutor at amtutors.com. And in this video, we're going to talk about the inverse of a function. So to find the inverse, we are going to switch x and y. So inverse, switch x and y. That's our little reminder, switch x and y. So how are we going to do that? We're going to take the x and y's, and we're going to just switch them. So this becomes 6, 3, and 2, 4, and 7, 9. And I'm going to use the same notation. So I'm going to put it inside of a set bracket. Those the little squiggles mean that it's a set of numbers. And then we represent that as G inverse. We put a little -1 up there in my exponent to let me know that these are inverses of each other. And when we're doing our chart, we're going to switch the order pairs again. I'm going to call this one x, xy. We'll just say that it's the inverse. So we're going to switch the 4 and the -1, the 6 and the -2, the 3 and the -3, and then the 9 and the -4. We switch the x and y. So this one is the inverse, and the y is how we name it. So I'd put the inverse on the y as notation, or you could just say like inverse on this side, depending on what your teacher wants. Now, when I have a graph, it gets a little trickier. We have to reflect over the line y equals x. So there's a line right here called y equals x. And I'm not using gridded graph paper, so it's a little harder to see. But we are going to fold this graph over that to reflect it. So it ends up doing like this. So for ones like this, if I'm doing them in class, I'm getting some ordered pairs. Like I'm looking at my graph paper, I'm getting some ordered pairs and flipping them to go graph them. But this is what's happening graphically. We're reflecting over the line y equals x. So if it's a multiple choice question, or if you have some graph paper, you can reflect it over the line y equals x. We're still switching x and y. It's just that's what happens when we do it graphically. Now, another question your teacher may ask. Is the inverse going to be a function? So we look at the original function, the y cannot repeat. So is the inverse a function? So we're going to look at the original. I'll move out of the way in just a sec. And the y cannot repeat. Or if we're looking at the graph, the horizontal line test. So look at the original of G. The x's become the y's, and the y's become the x's. So for our inverse, we know that the y's of the original are my x's. Did any of these x's or the y's repeat? No. So our inverse will be a function. Look over here. Did any of the y values repeat? No. So the inverse will be a function. So you can do that without finding the inverse. Or if you look at your graph, does it pass the horizontal line test? Draw a horizontal line. Let me get a different color. Draw a horizontal line. Oh, look, it touched here and here. It failed the horizontal line test. The inverse will not be a function. So that's something that your teacher could ask you. Without finding the inverse, that's how you can do it very quickly. Look at the y values of the original or do the horizontal line test on the original graph. I hope that was helpful. If you have any more questions, please reach out to us at amtutors.com. We have certified math teachers that would love to meet with you online to get you some tutoring sessions. Also, like and subscribe so you see the latest and greatest when we post it. Have a great day.